and I'm with a small specialized consultancy called Open Source Sense. We actually used to be Linux Foundation Consulting until we ran into problems with non-disclosure agreements and foundations. So we spun the organization out. I'm going to talk today about what it takes to make business-critical software or mission-critical software using open source. And it's actually a very, very big topic. So what we're going to get here is a very quick overview. For those of you who have questions and want to drill down, please find me after this session. We can talk. It really could easily spend we could easily spend a week on this topic in terms of the details. Now, one thing is, as we go through this, I'm kind of curious, the orientation of this group. Are you folks, how many people are more interested in the strategic elements versus the nuts and bolts best practices? Strategic. Nuts and bolts best practices. Oh, we got 50-50. Okay. Well, I'll try and cover both. Again, if you want more depth, find me after. I'd be glad to drill down with you. So the agenda that we'll talk about today, first of all, what do we mean by business-critical software, and particularly in the context of open source. Next, we're going to talk about the difference between technology and engineering-focused approaches and process-based approaches, which are typical to large organizations. Next, we're going to talk also about the issue of forking and technical debt, and maybe a little bit about building visibility within communities. But mostly I want to get down to the elements that are necessary in order to ensure that we've got business-critical software using open source. So what I mean by business-critical software here is systems or applications that are important to the strategy or the operation of the business and have to operate whenever the business is operating. So in other words, they're important, they have to be reliable. And some requirements here are implied. High availability, a recovery capability, comprehensive security, expert support behind the package. These are the things that we generally mean when we talk about business-critical software. And you folks are from the financial services industry, so you've already got a lot of software in this category, I'm quite sure. Now, when it comes to the best practices for building these kind of systems, this is not new for our in-house operational systems. And I'm sure that all of you have got mature practices in your organizations for the critical operational systems. What's interesting here is that when we start talking about open source as opposed to completely in-house controlled applications, the picture gets a little bit more complicated. So the fact is now you're dealing with development that's happening elsewhere. And if this is a core capability, there's a lot of development happening elsewhere. And so you've got everything from new features coming in, vulnerabilities appearing on a random basis, bug reports, new releases on a regular schedule, hopefully, new requirements coming from the community, dependencies creeping in from new releases and new modules that are put into the package. And then on the other side, you've got big issues like, which way is this project going? Are you going to emphasize the things that I need to emphasize in my business? And then how do we get clients involved in this project? And do they care? And what about business partners that are involved with this software? So now you've got all these other dimensions that are not under your in-house control. And so what we're going to talk about today is how do we manage this new complexity? Now, one of the things that's fundamental, and I'm going to talk about a couple underlying concepts here to get started. Our companies are process-oriented entities, if you will. Basically, industrial processes are used to build systems that are critical, in other words, that have to work. Top-down management, formal methodologies, processes with metrics all along the development cycle. And then the relationships with the customers are governed by contracts and SLAs. So all of this is locked down pretty tight in a contract environment. On the other hand, this part that's coming from open source is on a whole different basis. So you've got communities based on essentially collaborative processes. Decisions are made not by top-down management, but consensus, and officially around technical merit, but it may actually not be so pure as that, depending on the community. The processes for deciding what goes into different releases and what gets fixed and what's get added depends on the sponsors of the community, the developers, maybe the members of the community. A lot of the mechanisms, instead of formal processes, are done with tools and scripts, and the communication with the users is just through repositories, wikis. It's a very sort of amorphous sort of connection. Now, there may be more connection because of the nature of the internet, but it's totally unstructured in general. And so what this does is it creates a conceptual divide that is quite difficult for a lot of companies to deal with. I worked with a number of clients that had trouble understanding these differences and dealing with the impedance mismatch between these completely different approaches to software. I'll talk a little bit about the mechanisms to do with that. Another thing that's critical as we talk about these mechanisms, there's a lot of decisions that are different if the software that we're talking about is strategic to your business or whether it's just tactical. And some of the characteristics that help you decide which we're dealing with is on the strategic side. Probably the most strategic thing is that there's a unique ecosystem position that's critical here. In other words, the value proposition depends on, say, the universality of this project as a standard or as a common basis for interacting with the functionality that we want to bring to market. Another one is if we're trying to establish a new standard for doing something, a new process interface, for instance, in the industry. But strategic could also mean that the project just has unique functionality you can't find anywhere else. So it's strategically important. Or the implementation is uniquely compatible with what you're doing. In other words, say it's the only Node.js implementation, and the rest of your system is done in Node.js. Or just in general, the complexity and the nature of this is so complicated that the switching costs to a different project or a different technology is just too high to even think about. So those things force strategic. On the tactical side, this is software that really there's no ecosystem issue at all. It's more of an incidental piece of code. There's multiple implementations that you could pick. You can use interfaces. The interfaces are more or less interchangeable. So you've got other options to these minor pieces. Another theme that you're going to hear throughout as we talk about the best practices is this one around modification of open source and the technical debt that accumulates as you modify it. The reality is that modifying open source is very expensive. Now, of course, one of the reasons open source is great is because you can change it if you need to, and that can be very valuable. But when you do that, you incur a big life cycle cost, which is generally called technical debt. In addition to the initial design and coding of your change, you're going to have to integrate and test that with every new release and patch that comes from the open source community forever. And that just adds up, especially as you get more and more of these. It can add up terribly. There are a couple things you can do to help with this if you take a modular approach. So, for instance, instead of putting your patch in line with the open source code, you just put a hook in it and it lives in a different file. That can make the merging a lot cheaper. Another fact that you need to keep in mind is once you get to about 15, 20, maybe 25% of the files get modified, it would have been less expensive for you to start from scratch and build the whole thing by yourself. That's how expensive this debt gets with all of the updates and the complications of merging with what comes from the community over time. Forking is when you say, forget the community, I'm just going to take this code and pretend I wrote it. That is an option with open source, but you lose certain things when you do that. Certainly any association with the project brand or technology, all of the contributions that would come from other community members, the confidence about the integration because it's known to come from a reliable community, all those things are lost. Now you've got a one-off code, and any of the changes back in the community, if you have any sort of connection with that basis, are going to be lost. You've gone your own way. And so, that may be okay, but in a lot of cases, it's painful down the road. And I've seen a lot of companies end up regretting this approach. To be thought carefully. So now I'm going to get down more into the nuts and bolts here. A typical product development cycle looks something like this. Starts with product strategy, definition, planning, product development. After that, the testing to qualify for release, and then you launch and go into a cycle of maintenance and patching. Now, I have to apologize that this is an old-fashioned waterfall, okay? But we don't have much time today, and it's easier to lay this out in this context. In the case of agile methodologies, you typically have strategy and definition occurring up front, and then everything down through to launch becomes, or actually to qualification is an iterative process instead. But it contains the same elements. And then you've got a next release that, depending on how extensive it is, it may go back to different places in this cycle. This is familiar, and your in-house systems to build high-quality, business-critical software is probably built into this process already. So with open source, we now need to build links into the outside world. And so one place you're going to start is with the open source community strategy. And Dawn talked about this really from the specific aspect of contributing. There's more to that. It has to do with your strategic relationships with the community and a planned approach about how involved you are going to be with this community in order to meet your business objectives, and then how you're going to go about doing that. At the beginning of the cycle, you need to choose which open source you're going to use to build this capability. And the most important, of course, are the strategic ones. Typically, these are platform-level decisions. In other words, we're going to build this distributed computing environment on Kubernetes. And it's going to, that run environment is going to be mostly Kubernetes. So that would be a strategic decision, for instance. Another thing that happens as soon as you begin to look at this, you're going to realize that there are aspects that you want to keep proprietary and aspects that you want to contribute to the open source community. And so you need to go through what we call differentiation analysis, and I'll explain what that is in more detail. But these decisions about what to open source and what to keep are going to be chronic in a proprietary system. The other thing that you're going to do as you get down to product definition is the tactical decisions. Okay, what are all these other pieces that I'm going to pull in? In an agile development environment, these are going to occur iteratively as you cycle through the different levels that evolve at the different in the different sprints, for instance. Then, as you go to project planning, you're going to have to also do an open source integration plan and an open source test plan to deal with the community-related aspects. Then when you get to product development, you're adding, in addition to your own development, the bringing in and integration of the open source technologies. Immediately, you're going to start with your open source test program, which of course continues all the way through maintenance. As you get into product development, pretty soon you're going to discover a bug, and so you're going to need to invoke a bug reporting and an approach to doing patches and upstreaming of the fixes that you make. And then finally, we're going to manage the incoming patches from the community, merge them into our code on an ongoing basis, and then also, of course, you're going to get new releases. Typically, major communities will release once or twice a year, and you'll need to bring those in and merge them with all of your code. So these are the interfaces to the outside world of open source communities, which need to be designed in a way that preserve this business critical kind of reliability in your system. Going to drill down now. The community strategies will evolve as you go along, inevitably, because your company changes, the service you're building is going to change, and the communities are going to change. So, the markets are going to change. So, but of course, you want to start with an orientation and a plan, because there's many decisions down the road as we build the system that will depend upon what your strategy is around this technology. So, typically, companies will pick a set of important open source projects. In general, they will be all the ones that are strategic to the business in some way or other. In those projects that are important to you, you probably want to see committer and maintainer roles in those projects. That gives you control, influence, and the ability to get patches into those products on an ongoing basis. And those things are all important for controlling the direction and minimizing your overhead at working with the open source. The other thing is you're going to want to adapt your development teams to the open source project culture. Now, one solution that was talked about earlier is hiring people that were part of those communities. Well, they already know how to work with that particular community. They already know the culture. But in a lot of cases, that's not an option, and so you need to make sure that you give people the opportunity and the direction to learn about their project, learn how to be part of that culture, learn how to adopt the practices, and make sure that they've got the tools to work with the community in a seamless way. The next area is the evaluation and selection. This is probably the point of greatest leverage in this whole set of processes, because if you pick the right open source components and projects in the first place, you can either give yourself great leverage for success or a lot of headaches forever. So this is very important. Most companies require some kind of due diligence here. I have to say that in my experience of working with more than 300 companies to date around open source processes, that it's not adequate, particularly for business critical functions. Projects that are tactical versus projects that are strategic require different kinds of evaluation. So the tactical stuff you always want to do. You need to make sure that the architecture is right and it fits with what you want to do, that the licenses are compatible with what you want to do, that the security vulnerability history is good, and there aren't unfixed vulnerabilities, for instance, before you build something critical on this. You might want to look at the code quality to see if it's good enough to work with. There's documentation so you can understand it. And also, is there a good community behind it that's mature enough to stand up and keep this software running for the lifetime of your critical system? These things are basic. Everything better have these characteristics if you're putting it into a business critical system. If it's strategic, there's additional criteria. You need to have all the tactical criteria, plus, does this open source project fit into the industry in a way that will be good for our business? Does it establish the standard or the way of doing things, or the interfaces to partners that we are expecting because it's open source. Is the direction of the community compatible with the direction we're going in, or is it going to serve a different kind of market and a different set of technical needs down the road? Who are the other project participants, and what's their level of commitment? If something's important to you strategically, you want to know that you're not all alone in terms of this project and its success. The other issue is whether you really have an opportunity to participate in the project's leadership. If this is strategically important to you, you want to have a say about where it's going. You want to have a say about how resources are allocated. You want to make sure that you're a player in this technology. The next category and set of processes have to do with differentiation analysis. And this is really asking the question, as we create a new feature for our use of this technology, are we going to keep it to ourselves, or are we going to give it out as open source? And this happens again and again and again. Anytime you're taking open source in a commercial business context, you're going to have to answer these questions on an ongoing basis. And the answer should be what supports your company's product and market strategies the best. The other thing is you have to realize that the answer to that question may change next year as the communities change, as your markets change, as your partners and customers change. So the key here is to have some kind of mechanism for doing this agreed ahead of time. Otherwise, this can result in endless arguments in your company about whether to open source this or whether to keep it. If you've got a standardized way of making this decision, it will go much better. The other risk here, in fact, is, of course, you can make it simple in saying everything we build we're going to keep to ourselves. We're not going to open source any of this stuff. And the issue here is technical debt. These are things that, in fact, you could give them away and have them pre-integrated, and you can get out of the expense of maintaining this particular software feature or additional software for the life of the project. Why would you want to keep that when it has no competitive value, for instance? So that's the risk of not doing this correctly. Often neglected in a corporate environment. So the other thing to remember here is if you do features or customizations that the project won't take, they're going to be proprietary. You're stuck with them. One way that you can deal with this, and I think Don mentioned this, is you can pre-sell ideas. If you want to add a new capability or feature, if you talk to the committers on the project and you get them to understand that this is something that would be great and other people will want it, then they'll probably take it. But it requires that sort of participation. So the best practices here is to establish a standard evaluation technique that deals with both business support and customer dimensions. And you want to apply that to every single new proprietary feature proposal during the lifetime of that project. Next is integration and test planning. If most of the source for something you're building is coming from open source project, there's a great advantage in making your own internal processes for development and maintenance highly compatible with the project. So for instance, if you're doing a cloud facility and 90+% of the code is coming from OpenStack, you want to make sure that your engineering process is highly compatible and will mesh very easily with the way OpenStack develops and releases software. That seamless interoperability with the repository and the bug tracking and the release process will save you tremendous trouble down the road. Now, if that's not possible, obviously, you're going to have to figure out how to integrate these as best you can. Test and QA, need to be done even with the open source code. These are business critical systems. So before you integrate, you want to do essentially check the unit testing on the open source code, and you may want to add to that too, because if your requirements, for instance, some open source projects test very rigorously. Some just do the slightest bit of testing to see if it seems to work, in which case you're going to have to add to that suite, and you want to do those tests before you integrate. And then the other thing that's highly useful here, and again, this is towards minimizing your technical debt over the life of the project, is contribute the tests back to the project. If the tests only deal with the open source, they're not uniquely competitive to you. If you give them back to the project, they'll do the testing before you even get it. And as new facilities get put in, they will be tested and made compatible because they run your tests. So there's some real leverage there. Next is the open source integration. And you want to integrate directly from the open source trees wherever possible. Typically, the product teams have the option to choose releases and the cycles that work best given your business and your needs for updates versus the rate of the project and the updates that are coming from them. Again, at this point, we want to strictly minimize the customization of open source software. Every time you change something, you're going to maintain it forever. And so it may be quick in the beginning, but you got to remember you're going to pay forever. Whenever possible, you want to modularize the changes as opposed to making inline changes to the open source code. That reduces the cost of merging code in the future. And to the extent possible, you want to automate this with your continuous integration model. Next, the test program. And you do need to continue to test the open source for the whole life of the product. This isn't just a development aspect. And it is important to test the open source before you even begin integrating, and then as a whole with your integrated product. So typically, this is at a single module level, project and subsystem, maybe platform testing, and then a full integrated or functional testing as well. The best practices here involve contributing your test code back to the project to the greatest possible extent. That reduces the amount of work that you have to carry in your organization for the life of the product. And it's also really good to develop relationships with the open source project leaders. Again, for strategic projects, you're probably already trying to step up to become a committer. That makes this very simple. But you want to make sure that you have those relationships so they'll absorb your tests. Tests are not particularly competitive usually. If they have to do with open source only, they're definitely not competitive. And if you've got the right relationships, they'll love to take these tests up, and you don't have to bear the burden. Next is, what do you do when you find problems? Most successful organizations in this area upstream early, and Don talked a little bit about this. What's critical is you need to have the community and maintainer relationships in place so they will trust you and absorb these fixes and contributions quickly and reliably. If you've got your changes, you can retain those as your value added, preferably through modular interfaces. Now, even with large organizations like Samsung and Red Hat, where they've got lots of committers, the company's reputation and ID doesn't really guarantee upstream patch acceptances. The committers to assign, if you have committers on the project, though, your odds are much, much better. In a lot of cases, committers have the right to just take anything in their area that they're responsible for, And so if your company employs a committer on the project, you've got a very high rate of acceptance to your patches. Smaller organizations, their patches are going to be reviewed on merit. This is a place where relationships with the project committers are very important to getting things accepted. And in this case, it's also even more important to consider things like the project style, so your code looks like it fits in, the project roadmap, and whether this patch that you're adding fits into where the project is going in a way that's arguably of advantage. And these are the ways that you're going to get your patches accepted, even if you're a smaller organization with a minor relationship to the project. And finally, we've got to deal with the patches and new releases coming back down from the open source project. The fact is that if it's a major project, you're probably going to start seeing patches come back down within weeks of when you start using the software. And the complicated thing in here is there's 4 sources of these patches, okay? The open source project development is continuing. Your own project is continuing to develop. The open source project is producing patches on a regular basis. And once you've got a product out there, your team, your engineering maintenance team, is going to be producing new patches to the code that you've added to create your particular service. So we got this stream. It's a 4-way merge. Okay, and it is complicated. And I have to tell you that the complexity in this area has bogged down many companies. And major companies with great technical expertise find that all of a sudden they've got a merge that takes weeks or even months with each new release. And it affects the quality of their service and the competitiveness of their product. So some of the things that you can do here, again, strictly minimizing the customizations. This is the place where you really pay for all that technical debt. So that's your single best point of leverage here. If you keep the patches that you're retaining as private, as small and modular as possible, that reduces the complexity and effort to do these merges. If you cultivate the project relationships and communication so that what comes in and your version is on the same wavelength and compatible, you'll save a lot of trouble, and also you'll get more upstreaming so that there's fewer changes to merge. Investing in the project test code helps a lot because new features at the project will have gone through the test code you upstreamed already, and so you won't have surprises at merge time. And then there's a whole set of tools here that can help with this, and particularly if you're using the same tools as the project for these merges, you'll get the best efficiency you can. So that's the end of my very quick tour here about how to build business-critical products with the additional complexity of open source. We know there's many techniques well established, and probably in your organization you've already got a detailed rule book for how to build your business-critical applications. With open source, there are these additional techniques that have been proven by many companies now for building the business-critical process. They rely heavily on your already established development process, and then they add these processes that we've just done a quick tour of in order to reliably couple with the open source communities. And by employing these techniques, you can realize all the benefits of open source software, but at the same time maintain the quality and reliability of your business critical systems. Do we have any questions? We still have a little bit of time. Pardon?
I'm just trying to figure out why nobody has got their hand up yet. Sorry.
Well, about this deep, right? There's a lot to this. So is this obvious to everyone? Do you already know all this? Is that why no questions?
I have a question.
Yes.
About, I didn't hear you say this, but you might have. So my apologies if you said this. But what is, I mean, so the open source community, extant open source community, is really worried about what we call the freeloading problem, which is where major users of open source are not giving back in commensurate to their use. This has been off and on discussed for the last 20 years, and we've always thought that it was okay that they weren't giving back, because at the end of the day, maintaining your patches separate from the upstream version is not its own reward. So you end up giving the patches upstream just so you don't have to maintain them anymore.
Right.
Or backport them forever. Did you talk about that as the thing that happens, or?
Yeah, the discussion about technical debt, and then it showed up at several levels here. The fact is that freeloading has its own penalties. And, you know, if you're just doing a casual system, if you're writing an internal conference room scheduling app and you're freeloading, hey, the penalties aren't going to kill you. But if you're building a business-critical system and it's going to be deployed with real customers for a long time, you are going to have to go through all of this maintenance and coupling with the project, and freeloading is not a win. You will pay if you do that. Now, does that help the projects? No, it doesn't really, but at least as companies become more aware of this, they're disincented to take the approach.
So what do you do? I mean, if we're doing business critical software, especially in finance, these systems are going to have to exist for decades. I wrote a piece of open source. I actually started it in the last century. For you younger people, that was, you know, and it's still out there. In fact, it's in most of the major banks, and I still get support requests for it. In fact, the FCA seems to have gotten cottoned onto this bit of code actually doing something useful. None of them seem to want to pay me for this piece of code that I would say it's not even a large bit of code. But if we had to have a system and we want to know and to be able to convince regulators, etc., that this thing is actually going to be supportable in 10 years' time, which is not that long really for proper, you know, concrete over systems, what do we do? What do we need to do at the start and during the project to ensure that there is that, you know, for their failings, and they are many, Oracle will probably still be there in 10 years' time to support the system. But not all the open source projects, people just get bored and wander away. What do we do?
Well, the first point is the leverage you have at selection time, okay? You probably don't want to make a strategic decision for something critical in a banking system for a one-person project, right?
Yep.
And there are projects like that. I mean, you know, one guy in a garage in Romania, right? Great software, but that's all that's behind it. So when just to draw the analogy, if you're building, if you were going to a vendor for that software, you would look at their financials and you'd look at their support capability and you'd say, no, I'm not going to rely on that guy. They can't support me for 10 years. So with open source, you've got a similar situation. Now, with open source, you've got more degrees of freedom. So the fact is, I mean, and I think one of the things that's interesting is FINOS might be helpful here. I mean, some of these projects could be absorbed into FINOS so that you've got a focus for maintaining support for these projects. And I think that's a case. Now, I worked on a project with Airbus, for instance, and on those planes, they've got a 30-year maintenance window. So they had to decide up front before they chose to take some open source that they had a plan to ensure that there was maintenance for 30 years. And they had to step up, in fact, to providing a framework that ensured that support on the projects they chose. So I think, you know, those are the kind of options that are available. You know, with open source, what you get is more degrees of freedom, but you can't neglect to cover your requirements. I think we're kind of out of time officially, But if any of you have questions, I will be here for both days, and I'd be glad to talk to you about the ins and outs. As I said, there's a lot of depth in these topics, and I'd be glad to share some of our experience with them. Thank you.